This is exercise 6.3.14 in section 6.3 in MyLabs Plus, where we are told that we have a survey of 3,935 adults, 720 of whom said that they have seen a ghost. We want to construct a 99% confidence interval to estimate the true proportion of all adults who say that they have seen a ghost. So we're going to use our basic format for a confidence interval for a proportion. And we remember that our p hat is determined by taking the number in our sample who said they have seen a ghost and dividing by the total number of people who were sampled. So in our sample, we had 720 people who said they had seen a ghost out of a total of 3,935 people. That is equivalent to a p hat of about 0.183. That makes our q hat 1 minus that, which would be 0.187. So first we want to verify that we can confidently construct this interval. Is our expected number of successes n times p hat, or 3,935 times 0.183, at least 5? It most certainly is. It's 720.105. Is our expected number of failures n times q hat at least 5? Well, that most certainly will be as well, because if we take 3,935 and multiply by 0.187, we get over 3,200. Clearly, they are large enough. So we'll go on to construct our interval. We have a p hat of 0.183, a critical value which we get from our table of critical values. It's going to be 2.576, and in a moment I'll just remind you of how we get that number. And then multiplied by the standard error, which is our p hat of 0.187, times our q hat of oops, I wrote that down wrong, didn't I? Our p hat of 0.183 times our q hat of 0.817, and I see I wrote that down as 0.187. all over our sample size of 3,935. So again, we're going to work left to right. We're going to take 0.183 minus 2.576 times the square root of 0.183 times 0.817 divided by 3,935 to get our lower limit. And we get a lower limit of this interval equal to about 0.167. And then we're going to do the same thing with the plus in front of the critical value to get the upper limit. And we get about 0.20, no, excuse me, we get about 0.199. So we can say that we are 99% confident that the true proportion of all adults who have seen a ghost is somewhere between 16.7% and 19.9%. So let me remind you again as to how I went about determining the critical value in this case to be 2.576. Here we have the table of critical values for the standard normal distribution, and we're basically wanting to determine how many standard deviations out from the center of the distribution we need to go in order to capture the middle 99%. Well, we know that our table gives us the area from the center to the upper edge of that 99% interval. So here's the middle 99%, definitely not drawn true to scale. Half of 99% will be above, so that is 0.495. So we want to look in the body of our table and try to get as close to 0.495 as we can possibly get. Well, we find, oh, I see that I didn't copy enough of my table, but we find that it's somewhere right in between 2.57 and 2.58, a little bit closer to 2.58. So we could average the 2.57 and the 2.58. to get our critical value, which would be 2.575, which is perfectly fine to use. I made it 2.576 since it was a little bit closer to the 2.58 value. So that's where our critical value came from. It tells us that that's how many standard deviations we need to go out from the center of the normal curve in order to capture the middle 99%.